Alright, here's a circle with a radius of 1. I've labeled 4 points on there. The 4 points that cross the XY axes. So 1, 0, 0, 1, so on and so forth. So you can see that the radius of the circle is 1. This is called a unit circle when the radius is 1 unit. Alright, I tried to introduce a new concept yesterday of trying to find sine, cosine, tangent of angles where a regular right triangle doesn't really help. You know, we've been doing SOHCAHTOA this year in a right triangle, and I've always told you we're only finding sine, cosine, tangent of the two angles at the end of the triangle. We're not finding sine, cosine, tangent of the 90-degree angle, but there is a sine, cosine, tangent of 90 degrees. We just can't use that triangle like we've been using all year. We have to use kind of like what they did in the video yesterday, which the only thing they left out of that video was the circle. All right, that triangle that they were showing you in that video is really inside this circle. Kind of like when I explained to you the equation of a circle, I said just pick a point on the circle, connect it with a radius, and then how far over did you go to get to that point? That was your x distance, and how far up did you go to get to that point? That was your y distance. And then x squared plus y squared equals your radius squared, and that's the equation of a circle. X squared plus y squared equals radius squared. So the equation of a circle kind of comes from a triangle. So we needed this triangle to explain the equation of a circle. Now it's kind of backwards. We've been used to using triangles for trigonometry, but we need the circle to explain what the trigonometric function or the answer is to 90 degrees, 180 degrees, 270 degrees, 360 degrees. If you just plug in, say, sine of 180 degrees, let's do cosine. Say cosine of 180 degrees in your calculator. It'll tell you that that's equal to -1. All right, but if you think about a triangle, SOHCAHTOA, how are you going to get a negative answer? Every side on a triangle is positive. And how are you even going to get a 180-degree angle in a triangle? You're not. So that's what I'm saying. The traditional triangle for SOHCAHTOA isn't going to work when we start getting into bigger angles, which we're doing now. And it doesn't help explain why some trigonometric functions are negative. But that video yesterday does. So imagine that we have, say, this point is moving. All right, so we've got a point on the circle. If we were to make a triangle out of that, we'd go straight down and it'd be right there. So this is kind of what the video was saying yesterday. This is a very small angle. And if we made it even smaller, if we made our point right here, that angle's getting even smaller. And if we made our point even closer down here, it's getting even smaller. So that's what they meant by this angle is approaching 0. As we move this point down to 1, 0, this angle gets smaller and smaller and smaller, and so does this line that comes straight down, our y distance. All right, to get to that point, remember on the circle, it's over the x amount, up the y amount. So as that point, as y is getting smaller, as that point is approaching the point 1, 0, eventually y is going to disappear. We're not going to go up any. Once this point is right there, all we do is go straight across to get to it. We don't go up or down. So the y coordinate right here is 0. But that y coordinate is also the side that's across from our angle. So in sine, say we wanted sine of 0 degrees, the opposite side in our triangle doesn't exist. 0 degrees, that point is right down here. So sine, the opposite side of 0 degrees is 0, and the hypotenuse, well, the hypotenuse is always 1, because this is a unit circle. The radius is 1, and no matter what point you pick on the circle, the radius is 1, and that's always going to be our hypotenuse. So sine of 0 degrees is equal to 0. All right, now say we go the opposite way with our point. Say we're moving our point up, up, up the circle till we get to 0, 1. As the point moves up, this angle right here is getting bigger, until eventually this point gets all the way to here. This angle would be a 90-degree angle. It'd be that right there. All right, so what's happening? Which side is disappearing as our point is moving up? This x coordinate right here, which would be the adjacent side to that angle. So as our point is moving up to right here, which would be a 90-degree angle, now this triangle that we had as it was moving up, this x coordinate, this x side, is getting smaller and smaller and smaller. Remember, when it was way over here, it was pretty long, but as this point moves up, it's shrinking and shrinking and shrinking until this point's all the way up here. Now our x value is 0, and that's why that's the point 0, 1. The x value is the adjacent side to that angle. So if the adjacent is 0, that would mean the cosine of 90 would be 0. Cosine of 90 is equal to adjacent over hypotenuse, and the adjacent side is the x value. That's 0. Hypotenuse is 1, so cosine of 90 is equal to 0. Sine of 90, sine is the opposite side, so the y value is getting larger and larger. It's getting longer and longer as this point moves up until it's all the way a full length of 1. It's the same distance as the hypotenuse when it's right there. So sine of 90 is 1 over 1, which is equal to 1. So this is a tricky concept because you have to imagine this point moving on the circle as you're thinking about this. And that's why I posted that video yesterday, because he actually shows the triangle moving and you can see the opposite side or the adjacent side, the x or the y side, shrinking or getting larger. So it was a nice visual. That's why I put that on there. So hopefully that helped you guys. But the thing about the circle is you can go to obtuse angles. You could say your angle is way over here. So this would be your angle, like this. Now, this is where it gets kind of tricky, because say that's a 135-degree angle, you're not actually going to find the sine of 135 degrees. You're going to think of it as drawing your line straight down just like you did if it was over here. And now your angle is right there. So if this is 135 degrees, that right there must be 45 degrees, because there's 180 degrees in a straight line. So when you think of the sine, cosine, or tangent of 135 degrees, you're actually finding the sine, cosine, tangent of 45 degrees, because you're only working in one quadrant at a time. You pick the angle. If it's 135 degrees, you find that point on your circle, which is right about here, and then you always draw the line straight down to the x-axis. And that gives you a 45-degree angle right here. So that's kind of what I'm going to teach you to do today in the next videos, how to find like some specific angles, 45s, 30s, and 60s. The multiples of those come up a lot. And then later in the week, we're going to convert those degrees to radians. I know you guys have all used a calculator before, and you got to check the mode to make sure it's in degrees and not radians. Well, now I'm going to explain to you what radians are this week, and this is all kind of a lead up to that. What are radians? That's the big lesson for the week, is understanding radians, but it's complicated, so I've got to start you with this. So you got to get this down, like what are the sine, cosine, tangent of the multiples of 90? So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then all the way back to 360 degrees. 360 is the same as 0. So if you wanted to know sine, cosine, tangent of 180 degrees, well, this triangle, as you get to 180 degrees, this point is moving down, down. This triangle is getting smaller and smaller and smaller. It's basically the same thing as the sine, cosine, tangent of 0. The y value, this side opposite of your angle, goes to 0. The only thing that's different now is the adjacent side is a -1 instead of a +1. All right, so if you wanted to know cosine of 180 degrees, it would be -1, because the adjacent side is right here. That's the radius, so it has a length of 1, but you're going to the left, which, like plotting a point, is negative. So it's actually -1 over 1, which is equal to 1. So that's how you can get negative values for your sine, cosine, tangent, is if your angles are bigger than 90 degrees and you start getting into negative quadrants. Remember, the first quadrant is everything's positive, positive, positive. When you get into the other quadrants, at least one of your directions is going to be negative. You're either going to be going left or you're going to be going down in each one of these three. All right. I'll come back to this again later in the week when we use this again to convert it to radians. I just wanted to show you this as kind of an addition to what the video showed yesterday. I'm not really showing you anything new, except I'm going beyond 90 degrees here a little bit. But I just wanted to expand on what that video was yesterday and try and give you another shot at understanding it if it didn't make sense to you yesterday. But you're really not going to need this for Tuesday's homework. So that's why there's going to be 2 videos in Tuesday's folder. This one to reinforce yesterday's concept, and then the next one so that you can do the problems for today.